We need to take one more look at how to graph rational functions. Previously you watched another video on some steps to take to do this. I wanted to do one more graph so you could see the steps one more time. I'm going to use the rational function f of x is equal to x minus 1 divided by x squared minus x minus 6. I did go ahead and factor the denominator, so now I've got x minus 1 over the quantities x minus 3 times x plus 2. So the first step we want to do is we want to look for those vertical asymptotes. So what lines are going to go top to bottom that will restrict our graph? That deals with the denominator. So from the denominator, I want to find zeros. You've been doing this since Algebra 1. So x minus 3 equals 0 and x plus 2 equals 0. So x is equal to 3, x equals negative 2. Those are my vertical asymptotes. So I know that the graph has to be restricted right here at positive 3 and back here at negative 2. So we've got our vertical asymptotes. Now we need to find out, is it going to be restricted top to bottom? So we need to look for horizontal asymptotes. What we found in the other video is we have to compare the degree of the numerator to the degree of the denominator. So if we come back up into here, our numerator has a degree of 1. Our denominator has a degree of 2. So we learned that when the numerator is less than the denominator, then the horizontal asymptote is at y equals 0. So I do have, oops, let me put that back in place. I do have a horizontal asymptote coming right across the x-axis, and that gives us a good start. But now we need to find out, are we going to be graphing up here? Are we going to graph down here? What part of these areas are we going to be graphing? So the next thing I want to do is I want to look for a y-intercept. So I went ahead, and the y-intercept is wherever x is going to be 0. So I took all my x's and replaced them with zeros. So on top I have negative 1. On the bottom I have negative 6. So my y-intercept is going to be at the point 0, 1/6. Now that's kind of hard to find on the graph, so I'm going to exaggerate it just a bit. It's going to be like right here is going to be that y-intercept. But now I need to know what's going to happen right in here and what's going to happen right here. So I need to use some other, what I'm going to call points of interest. So I decided I wanted to know what would happen when x was at negative 1/2. So again, I went up into my function, and everywhere there's an x, I put in a negative 0.5. And when I work this through, which I've already done in the calculator, I find out that my answer here is about 1/4, so about 0.28. So at negative 1/2 and positive 1/4, we're about here. Okay. I also maybe need to know what's going to happen at 1. Well, I can do that one in my head. If I put a 1 in here, 1 minus 1 is 0, and 0 divided by anything is 0. So I also have a point at 1, 0. So this portion of my graph is going to get close to that negative 2, cross over, and come down this way. So this is part of my function. But I still need to know what's going on the right and what's going on the left. So I chose 2 more points of interest. I decided to let x equal negative 4. Again, in the original, every x got replaced with a negative 4. I'm going to throw that whole thing in the calculator, and I'm going to find out that I'm at negative about 1/3. So at negative 4, back here, I'm at negative 1/3 right about here. Well, because of these asymptotes, I don't need any other points. I know this thing's going to get really, really close over here, and then it's going to curve around somewhere and get really, really close down here. but that 1 point tells me it's in this portion, not this portion. Finally, I decided I needed to do something over here. So I went with x equals positive 4. So again, on top, I get 4 minus 1 is 3. On the bottom, 16 minus 4 would be 12, minus 6 would be 6. So I'm at about 1/2. So the point 4, 1/2 will help me with the last of this. So at 4 and up about 1/2, because of these asymptotes, I have to get close here and I have to get close this way. And that's what the graph of this rational function would end up looking like. It takes a little time, but it's not too difficult.